Welcome to the Transum Podcast, a monthly roundup of the new features on the transum.org website, providing mathematical puzzles, games, learning activities, and the ever-popular mathematics lesson starter of the day. Here's your host, John Tranter.
Hello and welcome to podcast number 94. And I'm going to switch things round a bit now. I'm going to begin with the answer to last month's puzzle, which was about a holiday on an island with a very strange weather pattern. At the time of writing, it had rained for 12 days since I'd been there, but luckily it never rained for a whole day. Rainy mornings were always followed by clear afternoons, and rainy afternoons were always preceded by clear mornings. There were 15 clear mornings and 7 clear afternoons in all. How long was I on holiday? Well, the first correct answer was received from Rick Blair, who also gave me the great idea of leading the podcast with the answer to the previous month's puzzle and finishing the podcast with the new puzzle of the month. He writes, "As an engineer, I always like closure to one problem before moving on to the next." Okay, good idea, Rick. Well, the second correct solution came from Jonathan in California, who is solving puzzles on the website a lot faster than I can create them. Thirdly, Will Ransom provided an algebraic solution. And that, rather than me read out, you can find in the newsletter, transum.org/newsletter, for the algebraic answer to the problem. Now, I too worked out the solution using Will's method, but later I had a eureka moment. The number of half days of the holiday are actually itemized in the question. Adding them together, 12 plus 15 plus 7 gives 34. That's the total number of half days, which is equivalent to 17 days in total. So I reckon that's a very quick way of solving this problem. But anyway, you can choose your method, and did you get it right? If so, wait till the end of the podcast for this month's puzzle. Right, so I'm going to talk about the things that are new on the Transum website, the things that have newly appeared in this last month of August. The first new resource to be launched was called Inertia Racetrack and was inspired by a game called Racetrack, or Le Zip in France. And it was described in Ben Orlin's excellent book, Maths Games with Bad Drawings. Ben tells how when the game first hit the US in 1973, it became a schoolhouse favourite. A rudimentary computer version at the University of Illinois proved such a popular time waster that school authorities banned it for a week. Well, I hope you don't find this game a time waster. In fact, I hope you find it to be a really useful learning resource as part of your vectors topic. Now, I've played the game against some of the students that I teach, and it's really fascinating trying to figure out the way you can speed up or slow down the racing cars under the conditions of only varying the components of the vector one at a time. And it gives you this notion of inertia. So have a look at that. The links to all the things I talk about now are in the newsletter, transum.org/newsletter. So please do check them out. A prequel to the popular transformations exercise has been created that only requires learners to name simple transformations given the pictures. The activity has been cunningly titled Which Transformation? See what I did there? Thanks to subscriber Mandy for suggesting the levels of this activity. I began to write an extension exercise for pupils to practice partitioning, but then got carried away, and it's now a set of puzzles with a very wide range of levels. I think most pupils can learn something by working their way through the levels, and I hope you enjoy it too. It's called Partitioning Clues, have a look at it, flip through the levels, see what you think. Would it work with the students you teach? The new Sequences Table Challenge is in 2 levels. That's like 2 different tables. The first doesn't include the series sum, the sum of a series, so would be suitable for the middle years of secondary school who are just learning about the nth term of a sequence. The second table will challenge even the most confident Year 12 student, I imagine. Not only is it self-marking, but the randomized values mean you can try the same challenge on multiple occasions with different results. Given the highest common factor and the lowest common multiple, what might the numbers be? So that's the question that is asked in this new level 6 of the HCF LCM exercise. I would use a Venn diagram and prime factors in my working, but is there a better method that you know of? Well, if there is, you can try it out. Level 6 of the HCF LCM exercise, and please let me know.
You can find Transum Mathematics at www.transum.org.
For those in the Northern Hemisphere, it's back to school time, and the Transum website has a list of resources you may find useful at this time of year. Don't miss the classroom display ideas, and lots of other things that I have in the past found useful at the beginning of a new school year. Please let me know if you have any suggestions to further develop this area of the website, but otherwise use it now because it's not much use during the rest of the year, I guess. Starting a new school year is a good time to remind you that once in a blue moon, well, actually much less frequently than that, the Transum server may stop working for some technical reason. And I just wanted to remind you that there is a backup, because there's another website, transum.info. It's hosted with a different web host, and it contains 99% of the functionality of transum.org, so it can be used until the main site comes back online again. So just remember that transum.info is the backup for transum.org. Marry Me is a 2022 American romantic comedy drama film starring Jennifer Lopez and Owen Wilson, who plays the part of a maths teacher. I was drawn into watching it last weekend, curious to find out how much mathematics would feature in the story, and surprisingly, a mathalon, and scenes of the students preparing for the competition were shown. I wonder how many people watching the film bothered to work out the answers to the problems presented, such as, what is the sum of the reciprocals of the even factors of 16? And a circle with perimeter 8 pi is inscribed in an ellipse whose width is twice its height. What is the area of the ellipse in square units? Well, that's a rare occasion where there's some good maths in popular films. I thought I'd mention that. Also in the media, BBC Radio 2 has the best radio audience figures in the UK, with a reach of almost 14.58 million listeners per week. So when maths is discussed on Radio 2, a lot of people are listening. I have often have Radio 2 playing in the background while I'm working on the website, but because of the time difference, I'm listening to the nocturnal programming. And one daily feature I hear, or nightly feature I should say, is called Midnight Mastermind. 3 questions posed by a member of the public about a different topic each day, and the DJ has to try and answer them. Yesterday, the topic was GCSE mathematics, so my ears pricked up. Anyway, this is how it went.
We're doing Midnight Mastermind, that's why it's not for now. We're doing it with Zoe in Twickenham, who sent me her chosen specialist subject of Zoe.
GCSE maths.
Right, so why have you picked this?
Well, I used to be a maths teacher.
Okay.
And I no longer am a maths teacher. I go into schools and talk about maths and to try and get students excited about it. But I'm still a teacher at heart. So, yeah, it's my specialist subject, of course.
Why do you think so many people, especially of my generation, perhaps, I don't know if we can say about younger people, why they've struggled with maths? So, first of all, before you answer, my theory is that some maths teachers, certainly at my school, were clearly brilliant at maths, but they couldn't communicate the maths to you.
That's really interesting. So that's definitely something I've heard from quite a few people that I talk to. And I agree. So I think that sadly, I think quite a few people have had sort of negative experiences of maths when they're younger. And that's kind of given them a sort of negative feeling towards maths. And that kind of cycle is quite hard to break out of. So maybe they got something wrong and they felt bad about getting it wrong. Maybe they were made to feel bad, kind of quite a while ago. And then they're sort of scared to try a question in case they get it wrong. And that cycle is quite hard to get out of. But I kind of believe that if people are given a sort of positive experiences at school in the early days, I think everyone can enjoy maths, and I think everyone can be a maths person. That's my hope anyway.
Shall I just tell you briefly before we go? I'll just tell you the best example of quick maths I ever witnessed, right?
Okay, go for it.
It was at the darts at the O2. And
fantastic.
As well as the scorers on stage who were lightning quick, Sky Sports would employ a former player to help with the camera crew to know where to point the cameras on the board, right? So when I did it, it was former world champion Keith Deller, who was one of the youngest, if not the youngest world champion, right? I think he was 16 or something when he won. Very, very young. And he was on a microphone just to the camera crew, right? And he would say, he's going to go treble 20, treble 17, bull. And if he misses treble 20, he'll come down to treble 19. And so he knew all the checkouts. And then if they were fraction out, say he'd gone for treble 19 but hit the bed next to it, he would know straight away, oh, right, in that case, he's going to, because the maths was there. And it almost becomes like rote.
Yeah, definitely. I think darts is a really nice way to get young people into arithmetic. And it's a great example of using maths.
Phil, you require a full house.
Midnight Mastermind.
On GCSE Maths with Zoe in Twickenham. Question 1, please.
Okey-doke. So 3 painter decorators take 6 days to complete a job.
Yeah.
They're working simultaneously. How many days would it take 2 of the painter decorators to complete the job? And you can assume that each painter decorator is equally efficient.
Right, so they're doing the same work.
They're doing the same work and they work at exactly the same rates. Yeah.
So 3 of them, 6 days. So how long would it take 2 of them?
Yeah.
I'm really nervous. Let me just work this out because I can work it out. Right, okay. So surely the answer is 4, isn't it? No,
and where does your 4 come from?
It's not going to take them less if there's 2 of them. It's going to take them more. Hang on.
Yeah.
You said what I did there. Can you see what I did? I did 6. You know what I did. I did 6 into 3 and then times it by the 2. So hang on. I'm sweating like I've never sweated before on national radio. So I can't do this under pressure.
Would you like a clue?
Well, no, I want to say 8 now, but I'm not sure how I've got there.
Okay. Well, it's bigger, which is good. Would you like a clue?
Yeah, go on.
Am I allowed to give you a clue? I don't know the rules of the game.
Well, I'll hit the wrong buzzer and I won't count it as a point, and now you can give me a clue.
I'll give you a clue, which is probably the best thing to do is to first of all try and work out how long it would take 1 painter decorator to do the job.
And then multiply it up by 2.
Then deal with 2.
Right.
So if you only had 1 of them turning up to work.
Yeah. Oh, right, okay, so it's 12.
And so what did you get? What's your logic there?
Well, it's a 6-day job, isn't it?
6 day if you've got 3 of them.
If you've got 3 of them doing it. Okay, so would it be an 18-day job with 1?
Absolutely, yes, because you've got that one person has got to do their 6 days, their friend's 6 days, and then another friend's 6 days. They've got to do 18 in total.
Right.
But now you've got 2 of them.
Half of that, so it's 9 days.
Exactly, yeah. So that person, they can share their 18 days out between 2 of them. And you've got 9 days. You got there. Fantastic.
I was only one away. It doesn't matter. I'm laughing out of sheer embarrassment. No, this is good. We need to push on with this. Don't be embarrassed about this.
That's good. And that is it's a pretty tricky one. So it's.
Oh, really? Okay, all right. It sounded really easy, and I thought, okay, go on then. Question number 2.
Okay, question number 2. We'll switch topics. We'll go for Which of the whole numbers
Yeah.
from 1 to 10,
Yeah.
including 1 and 10,
Yes.
are prime numbers?
Okay. A prime number being a number that can only be divided by itself and 1. Is that right?
Absolutely.
Okay.
Spot on.
So whole numbers between 1 and 10, which are prime numbers? So, 1 is 1.
I'll let you do the whole list and then
Okay.
I'll let you know.
Okay,
at the
fine.
end.
Okay. Can you sing a song while I do this?
That's absolutely not in my skill set, unfortunately.
What is the question? How many or which numbers?
Which of them? Just go through them and say which ones you think are and aren't.
Okay.
I can hear a pencil. Are you writing it
Yeah,
down?
that's me. Yeah, that's me. Actually,
Is that in the
that's-
rules?
That's not one. That's not one. So I think there's 4 of them, and I think it's 1, 3, 5, and 7.
Okay. I don't know if you can have half points in this game.
Go on.
So there are 4 of them, and 3 of them are 3, 5, and 7, which is great.
Yeah.
But
Why is
actually
1 not 1?
1 is not 1. So it's a tricky one. So the way, this isn't an explanation of why really, but a good way to remember that 1 isn't 1
Yeah.
is that your definition of prime number
Yeah.
was something that can only be divided by 1 and itself, which kind of helps us.
Fair enough. Fair
One
enough.
is
Whereas
itself,
1 is
so-
itself. Okay. Fair.
But-
Well, I don't mind. I'm not embarrassed by that. Okay. Fine.
There's a better explanation for why, but that's a good way to remember
Okay.
it.
But I've missed
and
1.
then
So there's 3,
you've
5,
missed
7.
one.
There's 1 more.
There's one which doesn't fit the pattern of the sort of numbers that are prime. So 3, 5, and 7 are all odd. And actually, there's one which is the only even prime, and that is 2. So 2 is the only even prime. Because every other even number is divisible by 2.
Yeah. Fair enough.
So you're really close. I mean, I would give you that, but I don't know if I'm allowed to.
Well, let's go to our adjudication panel, and Will.i.am.
I think Zoe's been very fair and lenient with you so far. So
That sounds
I'm
like
going
a
to throw
no
the
to
hammer
me.
down.
Right, there we are.
Oh, okay.
Okay, well, let's see if I can salvage some pride with question number 3.
Okay, question 3. A sequence starts 2, 5, 8, 11,
Yeah.
and so on.
Yeah.
And the question is 300 a number in that sequence?
Okay, so let's just go the question again. The sequence is 2, 5, 8, 11. You want to know, would 300 be in it?
Absolutely, yeah.
It's a bit late for this nonsense, isn't it?
Never too late for maths.
So obviously, well, I say obviously, the pattern is that you're adding 3 each time.
Yeah, that's good.
So now we need to work out if 300 will be in it. And given that 300 is divisible by 3, I want to say yes.
That's really good that you've noticed 300 is divisible by 3.
Right. But it's the wrong answer.
Well, what about the other numbers in the sequence? Are they divisible by 3?
No, that's true. So it doesn't fit that pattern.
This sequence that we've got, we could describe it as being 1 fewer than the 3 times table. So 299 would be in that sequence.
Now, I'm afraid contractually, right, I have to play myself some booze here, but it's only really for me, and it's because I got 0. But actually, I really enjoyed that, apart from the fact that you made me sweat profusely on Radio 2. It's a good job it's only radio, and there's not some kind of way of scratching the speaker and realising what's going on in this studio. Whew.
Well, I'm glad you enjoyed it. That's good to hear. Thanks very much.
So the DJ, under the pressure of answering live on air, got the questions initially wrong, despite the fact that earlier in the programme he'd said he'd achieved good results in maths when he was at school. Clearly, the fact that he's under pressure, so many people listening, and he's trying to answer these questions. So it made me think, how do you perform under pressure? And how do your students cope? And do you manage to get the level of pressure in the classroom just about right for your students so that it is suitably exciting, but not so much pressure that they can't think straight? Anyway, I thought that was worth sharing. Okay, so what we're going to do now is end the podcast with the new puzzle of the month. So, this a bit slightly different this week. When I typed the words viral maths into Google, the top search results had the following calculation, and I'll just read out the terms exactly as they appear. 8 divided by 2, open brackets, 2 plus 2, close brackets. Now, the puzzle of the month is to figure out what are the 2 different answers most commonly given for the result of that calculation. And out of those 2, which is correct? And you may be surprised to know that even calculators give different answers to this calculation. So you can't rely on just typing this into a calculator and saying that is the correct answer. So I'll say it again. It's 8 divided by 2, open brackets, 2 plus 2, close brackets. What are the 2 answers given and which one is correct? So the answer will be in next month's podcast. Until then, have a good September 2022. Bye.
Thank you for downloading and listening to the Transom podcast. You can find the website at www.transom.org, where you're welcome to use all of the activities absolutely free, or jump in with both feet and become a Transom subscriber.